All right, so welcome back to our last lecture for this semester. Today I would just like to talk a bit about what I'm calling case studies, which are kind of projects and applications of mobile information systems in the widest sense, which don't really fit into one specific category that we talked about previously, but which I think illustrate nicely applications that go across several subdomains that we talked about previously. So I would like to talk a bit about IoT in the context of the dash button, then also about things that you can kind of do with Android devices without actually having to root them. That might be interesting in some cases and might give you also a few ideas for future projects about things you can do without really having to rely on actually rooting the device, which is an additional hurdle. Then obviously one very timely application at the moment is all these contact tracing apps for COVID-19 cases. So this is also something I'd like to discuss a bit. Related to that is that a lot of people have switched to using mobile phone payments recently. So how does that work basically is also a scenario I'd like to talk about. And last but not least, a bit of a look into how computational photography works on mobile devices specifically. That means how can we use kind of algorithms to improve images taken with our mobile devices beyond what the camera hardware would actually be able to accomplish on its own. All right, so let's get started with the dash button. I don't know if you're familiar with this. This was kind of a hype thing from Amazon a few years back. That was a simple single button to order one specific product. So the idea is that, for example, you put this one next to your washing machine, and then when you notice that your laundry detergent is getting low, then you just push the button and then it blinks a little and the pattern tells you, okay, I've ordered a new pack of detergent, and that will then Amazon will deliver it to your doorstep. I think in the US you still can use these, and they're kind of a thing. In Germany, they're actually not allowed because for legal reasons, you actually enter a contract, like a purchase contract with Amazon, without actually knowing how much it costs, and that's not allowed in Germany. So for customer protection reasons, these are no longer available here. They have been here for a while, but they're no longer allowed, kind of. But this is kind of a very nice example for an IoT product. So this thing, of course, needs some sort of connectivity. But the user interface is basically the most simple interface you can imagine. It's one button and one LED. And so first, let's have a look what's inside there. Of course, we have a microcontroller that can actually be reprogrammed. So if you kind of dig deep enough, then you can actually write your own software for this dash button and flash your own stuff on there. Then we have a board antenna. This is this structure here on the PCB, which is a antenna directly integrated into the PCB. We talked about this, I think, in lecture 3 for a bit, that these are, of course, not the most perfect antennas, but they are very easy to manufacture because you can just directly build them along with the PCB. Obviously, we have the button, and somewhere over here also the LED, I think. Then we have a separate module for the Wi-Fi. So this is not handled by the microcontroller, but there's a dedicated module for all the Wi-Fi stuff. And last but not least, there's a microphone here. And when this dash button was introduced, then a lot of people were kind of up in arms about the microphone, and similar to Alexa devices, and said, oh, and now Amazon is putting even more microphones in our homes and listening to our conversations and so on. But this microphone actually has a completely different purpose, and the whole system is not really designed to transmit audio data anyway. For example, it doesn't have a rechargeable battery. It has one fixed battery that's soldered in, which is also not a good idea from an environmental point of view, of course, because then after maybe 2 or 3 years, the whole thing is just electronic waste usually, unless you actually crack it open and replace the battery by hand. But with that limited battery capacity, it wouldn't be capable of continuously transmitting audio data anyway. So that's obviously not the purpose of that microphone, to be like a spy device. So what is it for? And this is something I would like to talk about in a moment. First of all, now let's have a look at how do you configure this dash button, because there's kind of a chicken and egg problem with many IoT devices if you don't have a regular user interface. If you have something that has kind of several buttons and a screen, then you usually can, maybe it's tedious, but then you can always like put in the Wi-Fi name and the password with the little keys, and it might take 5 minutes, and it's annoying, but then you're done. But if you have just a single button and a single LED, how do you get the Wi-Fi password on that device in the first place so that it can connect to the internet? And yeah, so this is the big question here. And there's 2 potential ways to solve this. So one is kind of called temporary local hotspot, let's call it like this, and the other is to use some sort of side channel. Side channel can be anything that's not directly Wi-Fi itself, basically, and I think this might be a good opportunity for you to pause for a moment and think about what kind of side channel you could use here. Let's focus on the dash button for now, but this is of course a more widely applicable issue. So how do we actually get the Wi-Fi credentials into the device by using some kind of secondary communications channel? All right, so let's look at what ways we have to achieve this. The most straightforward approach, I would say, is what most devices today now use, which is could just be called local hotspot. So, for example, I had a Wi-Fi speaker a few years ago which used exactly this approach. So when you take the thing out of its packaging and turn it on, then it will open a like generic unencrypted Wi-Fi hotspot on its own, which is then called speaker 1, 2, 3, 4, 5, 6, 7 or so. And then you connect to that hotspot with your Android device. And the device itself opens up some sort of, I think it's called captive portal. That means whatever website you access with your browser, it will always redirect you to a tiny web server directly on the device, and that shows your configuration page. And on that configuration page, then you can enter the SSID and the password for the Wi-Fi you wanted to connect to, and then you push a button. Then the device closes the local hotspot and disables that local access point and connects as a client to the Wi-Fi network that you just configured. One issue which you sometimes have to kind of work around is that more recent Android devices are very keen on maintaining internet connectivity. So if you connect to a Wi-Fi network that does not actually have internet connectivity on its own, which actually applies to this local hotspot thing that an IoT device would open up, when you connect to that, then the Android device will very quickly detect that that hotspot doesn't have internet connectivity and will switch back to using like LTE or whatever. And then for that reason, it can sometimes be actually a little more difficult to access the configuration page, because when you enter just any arbitrary domain like, I don't know, uniweimar.de into your browser, the idea is that the local hotspot on the device will just redirect that access to the configuration page. But if your mobile phone has already detected that it doesn't have internet access via that hotspot, then it will not send the request to the hotspot on the IoT device, but rather to LTE. And that's kind of a problem sometimes. So you have to kind of fiddle around with the Wi-Fi configuration on Android from time to time to make this approach actually work. So this is the easiest one because you don't need any sort of extra hardware in the device, just the Wi-Fi module, which is configured differently either as a hotspot or as a client. However, Apple, for example, also Amazon included a way to use the side channel configuration. Also because the hotspot approach didn't work on iOS in the beginning already. So the kind of the same issue as with Android now, but more pronounced even. So, and this is where the microphone comes in. So the side channel here is actually ultrasound. So you need a specific app on the iOS device to configure this dash button, and it will then create a ultrasound pattern basically that is repeatedly played back from the device. As a human, we can't hear it, but the microphone in the dash button can pick up that ultrasound pattern and extract the Wi-Fi configuration, and then again connect to the Wi-Fi as a client. So of course, there are different additional side channels possible. For example, if you have a more recent Wi-Fi module that also includes Bluetooth Low Energy, then you could, for example, use Bluetooth to transfer the Wi-Fi credentials and have it then connect to Wi-Fi. Would also be an option. There's a really weird approach I came across a few weeks ago, which also only uses Wi-Fi, basically, but uses your mobile phone to send out extra discovery frames for other Wi-Fi access points. This is something that is part of the Wi-Fi standard. However, these discovery frames are actually intentionally kind of abused to carry the Wi-Fi credentials for the regular network that you want the device to connect to. And the device listens specifically for these discovery frames that have a couple of additional bits set, and then from the data in that discovery frame, it can extract the credentials for the actual Wi-Fi. So this is of course, a very, very error-prone approach because it's completely misusing a part of the Wi-Fi standard for something which it was absolutely not designed for. And so this is also very, very likely to break kind of at an inopportune moment, I guess. But so this is kind of an overview of how to actually get an IoT device to connect to a Wi-Fi network. There's various approaches, and the most common ones are either to just open up a local hotspot or to use some sort of side channel. All right, next up is a really mixed bag of topic, which is where I would just want to show you a couple of things that you can do on Android devices without actually rooting the device. So there's we've always already mentioned that Android is in general more open than iOS, so it gives you more options to kind of do things. It also gives you more options consequently to abuse things. And of course, you can always think of some sort of malware that can also use these to negative effect, but there's all sorts of apps that kind of cleverly work around the limitations of Android to achieve quite interesting stuff. So one thing that's very helpful is called NetGuard. This is kind of a user-level firewall or network filter, and at first glance, this is not possible on Android because to actually configure the firewall, you need root access, and then things usually get complicated because you need to kind of download some sort of hack first and then install some shady software on your device to actually get root access. However, what Android allows you is to have a VPN app. And for all sorts of vendor VPNs, there are regular VPNs apps in the store. And what these need to do, of course, is to kind of get redirected access to all network traffic from the device, so they can forward that through a secondary network connection to whatever VPN server they're connecting to. But the trick here now is that you don't actually open up a VPN, you just use this for network filtering. So all the traffic is redirected to your app, which is called NetGuard in this case. And then you can, for example, just block all the advertisement networks. So this is, of course, not something Google thinks that's very cool. So this is not an app that, as far as I know, is available on the Play Store, but it's an open source app that you can download and install for yourself. And then you can kind of get rid of a lot of unnecessary network traffic that involves all sorts of advertisement and tracking stuff, simply because Android has this provision built in for VPN apps that you can kind of use to work around the network filtering limitation. Another thing that I find quite interesting, I only found this quite low resolution picture, unfortunately, and currently this app is not in the store, but it's also a very interesting approach. This is called PixOff, and this will just turn into black individual pixels on the screen, and as you can see here, you can choose different patterns that it uses, so it will just like disable 20 or 30% of the pixels on your screen, more or less evenly distributed, to save battery. And of course, this only works for OLED screens. It does not work for LCD screens. And this is also something I would kind of ask you to think about for a moment now. Why doesn't this actually work on an LCD screen, but on an OLED screen? And as I said, you can select various patterns of which pixels to actually disable, so depending on which style you like best. I'm kind of assuming that this isn't really something that works very reliably on all sorts of devices. Therefore, it's currently not in the Play Store. Maybe there's another, like a successor app by now that works better. But the feature that Android actually offers that allows you to do this is that you can have an app that draws on top of other apps. So you can have all sorts of overlays over other apps. This is a special permission that you need to enable for that app to work. And occasionally there are issues with things like password dialogues. So these sometimes kind of can actually detect when another app is available that or is active that can draw on top of other apps. And then the app with the password dialog will, for example, refuse to let you enter anything for security reasons. Because if you have an app that can draw on top of everything else, then it could also show you a fake password dialog, for example, and then you enter your password someplace into an app that's not actually supposed to get the password. So that's kind of a security issue here. And there are other apps, like one is called Twilight, which is intended for kind of simulating a night mode if your Android device doesn't actually have one already. That also uses this feature that it draws extra content on top of other apps. And I really like the idea of using this to save battery on OLED screens. Still, of course, it's kind of a hack, so for that reason it's probably currently not in the store. But if you have an OLED screen, then you can maybe have a look if you find something similar. Another thing that's also interesting in my opinion is that unfortunately mobile carriers are kind of pushing people to buy a new phone roughly every 2 years, and so by now a lot of people have at least 1 or 2 old phones like collecting dust in a drawer somewhere. And I think it's often a good idea to try and kind of find a new second life, so to say, for these devices, a second use. And there's all sorts of apps also on the store that allow you to kind of give those devices kind of a second chance. For example, there's all sorts of so-called kiosk mode apps that kind of lock the device to a single app. And so I've kind of used this, for example, to turn an old tablet into a music player. So there's only a music player app running and nothing else. And so you don't even kind of start thinking about like using this for browsing the web or whatever. It's just there for playing music and nothing else. Also, what's quite often used is that you have some sort of web browser that's locked to a single page, and then you can build some kind of information display that just shows a specific web page and refreshes from time to time, for example. So all sorts of appliances or in the widest sense IoT things that you can kind of build on your own if you just like use an old device. One specific scenario for this is also surveillance. So there's also various kind of apps that let you turn your old device into a security camera basically for your room. So for example, there's Haven. This is an open source app which I think is actually also like endorsed and used by Edward Snowden. So somebody who definitely needs a bit of security in their life. And this uses all sorts of sensors to watch for unexpected, for example, unexpected sound, unexpected camera motion, even unexpected vibration and so on, and then record that data and also send you an alert on your primary mobile device, for example. So these are also, I think, interesting things to consider, especially if you have like an old mobile device floating around somewhere. Last but not least, what also I think is interesting to know about are these automation tools. For example, there's one called MacroDroid and Automate and so on. And especially if you look at Automate here on the right, then you have all these flowcharts with various sorts of branches and so on. And this is kind of getting close to actually being like a full development environment. And of course, if you think about how much information you need for developing, for example, a full-blown app on Android, like you need the developer reference open and you need all the different things inside Android Studio and so on. And that can take up quite a bit of screen space. Then, of course, it's the question how much functionality can we map onto such a simple space-limited touchscreen interface. Also something we talked about earlier. So how does the usability of such a relatively simple touchscreen interface hold up when we actually want to create more complex tasks and more complex data flows, so to say. And of course, these apps by necessity also have quite a lot need quite a lot of permissions for all the various tasks they can perform. And so, for example, it's actually quite easy to create a task that will lock you out of your own device. If you want your screen to lock automatically when you kind of are not within 5 meters or so, or your let's say your Bluetooth watch is not within range, then you want the screen to lock automatically, something like that. Then if you create such a task and just make a little mistake and confuse 2 parameters or so, then it would, for example, be quite easy to really have a hard time to get back into your own device if you mess this up. So here the usability can actually be quite important. And so I've actually tried to use this Automate app once or twice myself, and yes, you can like create really complex flows and task sequences. But of course, as you can imagine, it very quickly gets a bit difficult to kind of keep an overview of what's actually going on and which task is kind of fired by which other task and so on.